Simon, very much, and also thank you, Greg, and the organizing committee for inviting me. It's really a pleasure, a real delight to be here in your beautiful, beautiful city to present to you all. And I look forward to a wonderful 3 days of stimulating presentations and discussions. So I'd like to begin with something that I think is not surprising at all and to everyone here, and which really kind of lays out the challenge that we have with regard to non-pharmacologic interventions and health behavior change interventions. And essentially it is that it's been mentioned that changing unhealthy behaviors is really the single greatest opportunity we have to reduce premature deaths. This is from an article by Stephen Schroeder in the New England Journal of Medicine. Many of you may be familiar with him and with this finding, which is that, as you can see, he attributes 40% of premature deaths to behavioral patterns for which we need behavior change interventions. So we know that unhealthy behaviors matter a great deal to health. We also know that we can do something about this. Improving health-related behaviors can have very powerful effects on health, and this is the diabetes prevention program that many of you also are familiar with, in which a modest weight reduction, 7%, and 2.5 hours per week of activity increase led to a very large 58% reduction in the incidence of type 2 diabetes. And in fact, the non-pharmacologic intervention in this case, which was a combination of, as I said, exercise and weight control, outperformed the drug metformin. So we can see that our interventions can have a tremendous effect on health outcomes and really have an impact. But we know there are limitations to our interventions, and we know we need to develop better behavior change interventions. It is very difficult for most people not only to initiate changes in their lifestyle behaviors, but also to maintain those lifestyle behaviors over a long period of time. And this is just a demonstration of that from the Trials of Hypertension Prevention 2 trial, in which you can see the typical check mark of weight loss studies. Anyone here who does weight loss research knows that it is pretty easy to have people lose weight over the 6 months, but that people generally start to drift back and gain that weight back, and oftentimes go right back up to baseline. And so we need better, longer lasting, more powerful behavior change interventions. The challenge is, how can we design these interventions? Well, what I'd like to argue is that in biomedical research, there is a well-defined translational process that Greg alluded to that guides the development of new basic biological discoveries into efficacious therapies. And that building better non-pharmacological interventions depends on a similar process in which we accelerate the translation of new and innovative ideas, which are concepts, theories, findings from basic behavioral science, into more powerful, efficacious interventions. And I'd like to just demonstrate, we all know the translational research spectrum, in which we have basic science discoveries that are used to develop new treatments, the bench to bedside sort of link. And then we have later phase, T2 to T4 translation, which is taking those proven therapies out to clinical practice and community settings. And I'd like to say that both aspects, all aspects of this translational paradigm are critically important. But this can be applied as well to health behavior change research. So, as I said, this piece The later phases of translation have to do with taking proven therapies, disseminating them, and implementing them in public health, in clinical practice settings, an absolutely critical piece of this translational spectrum. And we do not do enough of this and do it well enough. So it is a critical need. But I'd like to argue today in this talk that actually we need to pay more attention to this earlier phase of translation for behavioral science, T1 translation, in which we, again, take basic behavioral science discoveries and translate them into developing new treatments. Now, this early phase, or what I'll call T1 translational behavioral research, the terms in terms of T1 and T2 translational research are used quite differently in biomedical and behavioral research. So if you ask a biomedical researcher what translational most often is used to refer to, or what it means, they usually use it to refer to this T1 early phase research, bench to bedside. In behavioral research, when we talk about translational research, often we're talking about those later phases. Often we neglect to think about that early phase of translational research. It's important also to realize that, that this translational spectrum is bidirectional in nature. It goes back and forth. Findings from basic science are translated into clinical applications, but what we observe in the public health sphere and in clinical practice can also be the basis for taking that back into the basic science realm and bringing it back through the spectrum. So really there's an iterative bidirectional kind of thing going on. Also, I have to emphasize that the translational research I'm talking about often involves or requires transdisciplinary or interdisciplinary teams and approaches, because you have to have, at the least, people who have expertise in the basic behavioral science as well as clinical expertise and in multiple disciplines. But I'd like to argue that T1 behavioral research remains a relatively under-recognized and under-resourced area. Again, we don't often think about it as a field, as an area of research in its own right, developing behavioral interventions. And why is that? Well, as Greg just illustrated so nicely, we don't really have a widely accepted framework the way they do in drug development. We have many frameworks, but what I'd also like to argue, Greg, is we have many frameworks. It may be that we do need a common framework, but people often don't use the frameworks that are out there. Yes, exactly. Often people develop behavioral interventions in ways that are not systematic and progressive. So I would say another need is really to use a framework. We also don't have industry support. Of course, pharmaceuticals, drug development is an entire industry, very well supported. For behavioral interventions, we just don't have that. We have few funding opportunities. And we have some institutional, cultural, and systemic barriers, I think. Lack of, again, academic recognition for bringing together the basic behavioral and clinical fields of study. This kind of research is very high risk as well. As we all know, interventional research is in fact high risk research. You may or may not have a positive finding. In early phases of research, you're most at risk of quote unquote failing to find an effect. You may run into sort of blocks and not be able to move forward. So it is kind of high risk and often costly. And there just are few incentives, really, for the kind of interdisciplinary teams that you need to do this kind of research. So one of the things that the NIH did about this is to develop a program of research that was called the Obesity-Related Behavioral Interventions Trial program. And the objective was to translate findings from basic research on human behavior to develop more effective interventions to reduce obesity and improve obesity-related behaviors. This was a trans-NIH cooperative agreement consortium supported by a number of different institutes, and we funded 7 research sites and 1 resource and coordination unit. We had interdisciplinary teams of researchers at each of these sites that were charged really with developing novel obesity-related interventions. This is just to give you a sense of the 7 research projects, and they varied quite substantially in terms of their focus. I won't go into detail about them, but certainly would be happy to speak with folks about them afterward. One of the things that the Orbit program did, in addition to the individual projects and their research and their findings, was to sponsor workshops about pressing issues in this field. And one of the workshops posed the question, just exactly the question, just exactly the question we're talking about here, which is what model or framework can we use to guide the behavioral development process, intervention development process. And we all were very aware of the drug development process. Again, just to show you that, and those of you who are familiar with it, is a phased model. Phase 1 is all about safety and all about dosing, coming up with the specific doses of the drug. Phase 2, you look for evidence of efficacy in small-scale trials, and phase 3, larger trials of efficacy. And we asked ourselves, well, why do we need a framework? What does a framework do for you? So what I would say is that even though the drug development model has flaws, certainly, it's not perfect, but it's resulted in the creation and testing, you cannot deny, of many life-saving and life-extending treatments. And so by using a framework, we believe you can better define the process by which you develop your interventions. This, we think, is going to accelerate the flow and development of new innovative approaches to changing behavior. It's going to encourage the development of behavioral interventions that are well characterized, appropriately tested, and optimized prior to testing in large-scale, expensive phase 3 trials. So this should ultimately, hopefully, lead to better, more powerful behavioral interventions. And lastly, we believe that it will lead to the identification of failures, again, quote unquote, null results earlier in the process. So again, you can refine interventions early on and reduce, again, prematurely testing weaker behavioral interventions in those large and expensive phase 3 trials. So how do you do this? How do you move from basic behavioral science to clinical application? Well, and how do you develop a framework? What does that look like? We thought, and again, there are many, many frameworks out there. They all have their good points. We decided there were some elements that we wanted to especially emphasize in our framework. We thought it was very important to define the goal up front, to begin with the end in mind. What are you trying to achieve? What is the pressing clinical or public health issue that you are trying to address? Have that firmly in mind and have it very specifically in mind. Secondly, identify the ideas. Obviously, have a good grasp of the basic behavioral, social, and biological science behind your intervention, the theory, the research. then obviously you need to define a pathway from the ideas to the final goal. And we believed that should have certain elements. Again, it should be progressive. So our model is linear in presentation. It certainly is bidirectional and flexible and iterative. However, we want to emphasize that you really are moving forward with our model. It's a progressive model. You are moving towards efficacy, towards effectiveness in implementation. As I said, it's flexible, it's bidirectional. We thought that was very, very important to be able to move backwards and forwards through the model. It defines milestones for success at each stage of the model, a priori, and that is important for moving forward. It also allows for quote-unquote failure, and I put that in quotes because failures, I don't believe, are really failures. They're just opportunities to learn, and I think we do need to understand that better. One can return to earlier phases of the model and to better understand certain aspects before moving on. So what does the model look like? Greg showed this. Even though we do represent all the phases out through the efficacy trial and the effectiveness research, we focus in on these early phases of intervention development in our model up to the efficacy trial. So just rather quickly going through and giving you some examples of some different aspects of the model. Again, we begin with the end in mind. We begin with what we call a significant clinical question. And this can be a health issue that poses a significant problem. Maybe a disease is increasing in numbers or in severity. Maybe there's a health problem, no treatment really exists, or you need to optimize treatment. Maybe you require a new approach, or there's a novel risk factor. And of course, an example of that is obesity. In the US, certainly, and around the world, obesity has been rising, and it continues to rise in adults. There are 2/3 of US adults and 1/3 of children are either overweight or obese. This is an enormous problem. And we know that increases risk for cancer and other chronic conditions, diabetes, heart disease, stroke. So aspects of obesity and the behaviors that lead to overweight and obesity, trying to change those, to improve those, is a critical, very significant public health problem and question. The next part is marrying that to some basic behavioral and social science research, and an example of that is some of the neuroscience that has been coming out, the wonderful work that's ongoing about the neuroscience of eating behavior. We know there are different aspects, there are different parts of the brain that control different aspects of eating. So you have sort of the accelerator and the brakes issue. You have one piece which has to do with impulsivity, immediate gratification, overriding the homeostatic energy system, and you have another, and that's a reward pathway. You have another, the prefrontal cortex, the executive functions that are really sort of the decision-making aspects, planning, self-monitoring, again, pursuing goals and delaying gratification. The implications of these findings in the basic neurosciences for our interventions are obviously you want to avoid triggering that reward circuit. Removing temptations from the home is one example, but there are many examples. And enhance executive function. So on the other hand, really reinforce that piece of it, training in inhibitory control, self-management, etc. So we have many basic behavioral science findings, very similar, that can be brought through to develop new interventions. The next part of this is that you then take that significant question, the basic research, and bring that into a phase one, which is a design phase. This is where you define the intervention and you refine the intervention. So you define the scientific foundation, the basic treatment elements of the intervention, identify the behavioral risk factor target, provide the basic behavioral and social science research basis, describe the pathways and the candidate intervention components. And then as you move to the next phase and refine the intervention, you're identifying essential treatment components and you're determining aspects of the delivery. How do you deliver the intervention? What does the intervention really look like in terms of putting those components together? Do you need to tailor it for different subgroups? And an example of this is a project that was done in the Orbit consortium by Dr. Len Epstein, who's done a lot of work on childhood obesity and developed programs of intervention for children and their families. And what Len was interested in was whether you could take a rather old concept, the concept of habituation from learning theory, the idea that over time, over a series of trials, individuals stop responding to stimuli. And he thought, wouldn't it be interesting to take that concept and apply it to dietary interventions to see if you could get children and their families to eat foods that were more healthy for them by increasing the variety of healthy foods in their diet and by repeating in order to have them habituate to the unhealthy foods. So the first step of that was really showing that this principle of habituation applied to eating behavior. And he ran a series of trials, some with animals, some with humans, and showed that indeed you could show a habituation response to food, whether it was changes in salivation across trials, and you can see that obvious lowering of response over time. And then when a new food is introduced, you immediately see an increase in response, whether it's salivation or working, doing a task for that food. So he did prove that, and again, that was a really definitional, foundational set of studies in that first phase of the model. Then he went on to refine the intervention content, and he needed to know specifically if foods are similar, how similar do foods need to be in order to elicit that habituation response. In other words, if someone is eating elbow macaroni and cheese, and they're introduced to a different shape, it's still macaroni and cheese, but it's a different shape. Is that different enough? Is that considered a novel stimulus? Is that going to continue the habituation response? Or will people respond as though that's a novel stimulus? And he needed to know that because he was writing, again, a dietary recommendation and prescription for his intervention. So he needed to know this detail. And indeed, he did some studies, and this is one in which he had children, again, responding to little tastes of food. Now, these weren't big portions of food, little tastes. And you can see, again, the downward response, habituation response. Some children got elbow macaroni and cheese. Some children got spiral-shaped macaroni and cheese. And some children got a completely different type of food, chicken nuggets. What he found is that over time, for all those foods, people habituated, children habituated, and responded less. But then when he introduced a different food to them, they responded differently. The children who got the same food as they had gotten before, if they got the elbow macaroni and cheese, and they got that again, they habituated. They showed habituation. What can I? No, it's wrong. They showed habituation to the same food, which would be expected. Interestingly, not so surprisingly, those that got introduced to a completely different food, the chicken nuggets, that they acted as though that was a completely novel stimulus. Of course it was, so that made sense. What was interesting is those that got the spiral-shaped macaroni and cheese responded similarly to those that got the brand food. So that change in shape was enough that it eliminated the habituation response. And sometimes we're surprised. I mean, this always reminds me of how we have a million different shapes and types and flavors of snack foods, and now we know why. This is exactly what they're doing, and they've probably done this research and know. But Len obviously needed to show that, and he did. All foods are not alike, and that went into his further studies. So moving on to the next phase, which is preliminary testing. Once you've developed the intervention, you have the components, you characterize the components well enough that you know how they're going to act. You do some preliminary testing. The first type of that is what we call proof of concept studies. So you want to show that the intervention can achieve a clinically significant signal on the relevant behavioral risk factor. An initial test. So these are typically not randomized. They don't necessarily even need a control group for these very small N studies. And then you go on to what we call pilot and feasibility testing. The pilot work is a term that is often used for these types of studies. These are larger samples in which you have a control condition, but as we'll hear later in the program, the term pilot may or may not be the best term to use here. But the idea behind this is, first of all, to understand the intervention's effects a little bit more with a larger sample, and to understand what control condition you might want to use in the next phase, the larger phase 3 trial, and also to do some work around feasibility. Is the intervention feasible? Are the numbers that you'll need available for screening and recruitment? And estimating the yield, the screening to enrollment ratio, the dropout rate, crossovers, adherence to treatment, all those very specific things that we need to know before we go into a very expensive phase 3 trial. So here we have a proof of concept series. This was a very, very early series of studies in 1967 that were done using behavioral techniques, behavioral modification techniques, some of the earliest work that was done that actually led eventually to the intervention that was used in the successful diabetes prevention program. But it began with these kind of small N studies in which you simply applied the intervention and tracked people's behavior over time. And the idea is you're not looking for statistical significance here necessarily. You're looking for a pattern. You're looking for a signal. You're looking for something that will show you, yes, something is going on there, I can move on. And this next phase, for Len Epstein's work, his next phase was actually putting this idea of limiting dietary variety into his family-based obesity treatments. And so for this, he randomized 24 families. Each of them had an overweight or obese child, 8 to 12 years old, randomly assigned them to his usual family-based therapy, or to his usual family-based therapy with additional prescription or instructions to the families about repeating over time, over their meals, the foods that were not so healthy. So what he was trying to do was, again, bring this idea of habituating to the unhealthy foods into a family-based intervention setting for obesity. And indeed, he found some very good outcomes. Child percent overweight was lowered in the intervention condition that used the habituation principles, and the variety of red foods or unhealthy foods consumed by the family was also significantly lower. And this just shows the results for both child BMI and also parent BMI, which also was reduced. So again, just to reiterate some of the key features of the ORBIT model, as I said, begin with the end in mind. The process is guided by significant clinical questions. These are often from end users, the patients, the providers, sometimes the system of care. Progression takes place from basic to more clinical or applied stages. There's a push towards the efficacy trial, and that's an important element. Each phase has clinically meaningful milestones before one can go to the next phase, and those are specified a priori. And there was an emphasis on achieving not just clinically significant change, not just statistically significant change, but clinically significant change in the behavioral target you're after. So it really is making a difference. There's flexibility in the terms of the numbers and types of studies, the duration of each phase, movement from one phase to the next, and you can move backwards and forwards depending on if you do not find what you're expecting and need to go back to an earlier phase to refine it. So just a shameless plug, sorry. We do have a workshop. I have a workshop with Ken Friedland a little bit later. If you are curious about some of the specifics, some of the methods, and want to delve a little deeper into use of the ORBIT model, please come see us on Saturday to talk a bit more about this. And I want to thank all my colleagues who participated in ORBIT, especially, as you can see, Linda Powell in the ORBIT t-shirt, my co-conspirator in many of these endeavors. Yes, that is Leonard Epstein up there tucking into what looks like a macaroni and cheese plate. I think it's just a pasta dish, but anyway, we rib him about that all the time. I want to thank all of my colleagues who have contributed to this, and happy to answer any questions you may have. Thank you for your attention.